Hello students, welcome to Spectra Education Academy. In this video, I am continuing explanation for the previous NEET questions from the chapter Gravitation. Question number 9. The body weighs 200 newtons on the surface of the earth. How much will it weigh halfway down to the center of the earth? So, when body goes down, so we need to continue with the equation G depth is equal to G of 1 minus T by R. So as per the question, D is mentioned as R by 2. So let us substitute GD, G at a depth D. So therefore G of 1 minus R by 2 with R. So this R and R get cancelled. So this is G by 2 is equal to at a depth. So it at this depth halfway down. So G becomes G by 2. Suppose if you multiply both sides same. So now it will be weight. So now we are trying to get weight of the body at a depth equal to R by 2. It is mg by 2. So this mg is the weight of the body on the surface of the earth, that is given 200 by 2. So answer is 100 newtons. So first option is correct. Moving to the second question, next question. This question is question number 10. Work done to raise a mass m from the surface of the earth to a height h, which is equal to radius of the earth. So therefore, work done. So when we are on the top surface of the earth, we possess potential energy as potential energy, or you can say U1 is equal to minus gmm by r, because we are at a distance equal to radius of the earth from the center of the earth. So now question is, work done to raise a mass m from the surface of the earth to a height h, which is equal to radius of the earth. So therefore, we are taking the body to a height equal to radius of the earth. So you call this is E2 minus gmm by r plus h. So difference only we are talking about. So W2 minus W1, that is equals to minus gmm by r plus h. So h is dimension which is equal to radius of the earth. So h is r only. That is minus subtracting W1 minus gmm by r. Therefore, LCM is 2r. Then this is going to be minus gmm plus gmm. So finally, you'll get G 2 gmm, because 2r is the LCM. 2 gmm by 2r. So, but we need to express this in terms of small g. So get the relation G is equal to gm by r square. So we can make that this particular part, let us make it as gm by r with m by 2. So from this gr can be written as gm by r. So therefore the final answer is gm by r has to be replaced with the gr. So m gr with m by 2. This is the answer. So I think the last option is correct. Going to the next question. So earlier question number 10 was connected to weight at depth D. Now this question is connected to weight at height h, I think. Yeah. The body weighs 72 newtons on the surface of the earth. What is the gravitational force on it at a height equal to half the radius of the earth? So therefore, h is equal to r by 2. So now Let us write acceleration due to gravity. Gravitational force means what? Now they are asking us to find out weight only. So therefore, G on the surface of the earth. It is once again Gm by r square. G at some height. So writing the same equation, r plus h whole square. This is question number 11. So GH by G. So dividing these two. So you'll get Gm by r plus h whole square divided by Gm by r square. So Gm get cancelled. So this is r square by r plus h. So h they mentioned h by 2. H they mentioned r by 2. This is r by 2 whole square. Now r square. So 2r plus r, 3r, 3r square, 3r by 2 whole square. So therefore 3r whole square. So this is right. This is r square by 9r square plus 2 square will be 4. That will go up. So 4 by 9. So let us multiply and divide mg. So this is 4 by 9. Then we are looking for weight at height h. That is r by 2. This is given 72 is equal to 4 by 9. So this is 9 8. The answer is weight at h is equal to r by 2 is 32 newtons. So second option is correct. This is given in NEET 20. Next, moving to question number 12. Escape velocity from the surface of the earth is v. Escape velocity from the surface of another planet having radius 4 times that of the earth, same mass density. So therefore, get back the escape velocity to Gm by r. So, but they are mentioning same density. So let us transfer this equation in terms of density. 2g density into volume divided by r. So therefore, 2g rho volume of the sphere. Earth is a sphere. It is pi r cube divided by r. So this one gets cancelled. So therefore, density is same. Acceleration due to gravity is constant only. So now we have variable quantity here. Escape velocity is 1 by. Escape velocity is directly proportional to r. So therefore, because this is r square root r. So r only. So escape velocity 1 by escape velocity 2. So this is on the earth, this is on the planet. This r1 by r2. On the earth they mentioned v. So we are looking for escape velocity on the planet. So this is r. They mentioned this is 4 times. The second planet is having radius 4 times that of the earth. R and R get cancelled. So escape velocity 2 is. So the last option is I think correct. Yeah. Next, moving to this is again based on conservation of energy. The particle of mass m projected with velocity. This is the velocity k times of escape velocity, but they mentioned k less than 1 from the surface of the earth. So v is escape velocity. We need to find out maximum height above the surface reached by the particle. So now total energy on the surface of the earth is equal to total energy at height h. The total energy on the surface of the earth, on the top surface of the earth is Gmm by r only. This is the potential energy, gravitation. Yeah. And there is also velocity with some velocity is projected means it also possesses kinetic energy. So this is the total energy on the surface of the earth. When it reaches to height, assume that final velocity is going to be 0. So it only possesses r plus h. So this h we need to find out. Now let us continue. Yeah. Minus Gmm by r plus half m. V they mentioned to take k square because V is kV. V is kV. V square is k square and escape velocity square is equal to minus gmm by r plus h. Now minus gmm by r plus half m into k square. Get back the escape velocity equation. The escape velocity equation is 2gm by r. So when you square it, root get cancelled. So it will be 2gm by r is equal to minus gmm by r plus h. So we can cancel gmm, and gmm. So this 2 and 2 also get cancelled. Yeah. So now you are left with minus 1 by r plus k square by r is equal to minus 1 by r plus h. Now let us try to simplify this. Here r is the LCM. This is going to be k square minus 1 is equal to minus 1 by r plus h. Otherwise, we can make this is minus cancel, this is plus, this must be minus. Now, okay. This is going to be minus r k square plus r, finish. Then minus hk square plus h is equal to r. If you take this side, so the minus these two quantities get cancelled. Then take minus rk square is equal to right side you take. This is going to be hk square. If you take out common, this will become this is minus 1. After you take this right side, it will become minus 1. You can take h common. Therefore, okay, if you cancel this minus, this become minus k square, this become plus. This become minus k square, this is plus. So h is equal to r k square by 1 minus k square. So fourth option is correct. It's not r square k, r k square. Moving to the next question, 14. Body of mass 60 kg experiences gravitational force 3 newtons when placed at a particular point. The magnitude of gravitational field intensity. So therefore, E is equal to F by mass, gravitational force by mass. They mentioned this is 3 newtons. Mass is 60 grams, 60 into 10 to the power of minus 3. So it will be, if you take minus 3 up, this will be 3000 altogether. 60. Therefore, this is 50. So last option is correct. This is question number 14. Now, so question number 15 is just like match the following type. So they are asking us to match the dimension formula. The first thing is gravitational intensity is force by mass. Let us try to start from the last. Gravitational intensity is force by mass. So force is ml square t minus mlt minus 2 by mass. So this and this get cancelled. It will be LT minus 2. So make it this third option as LT minus 2. So by mistake it is printed like that. Then this is D matches to 3. Then gravitational potential. So gravitational potential first you can get the expression of G mm by gravitational potential means work done per unit mass. Work done per unit mass. So W is, you might know, ml square t minus 2 dimensional formula by mass. So therefore, This is L square minus A. This is gravitational potential. So therefore, gravitational potential matches to first term. So therefore, C for C first one. Now, gravitational potential energy. So energy, any form of energy will have the same dimension formula, maybe kinetic or potential. So therefore, energy dimensional formula is ml square T minus 2. And the last, so you might know gravitational constant. So this is the way to get the gravitational constant dimension formula, gmm by r square. So F dimension formula of F is ml T minus 2. There is r square, L square will come here. G mass dimension formula is mass only. So therefore, 1m get cancelled. So if you take this side, m to the power of minus 1, L cube T minus 2 is the gravitational constant. So therefore, this is ml square T minus 2 means potential energy is both B4 and 1, I think 2. 1, 2 in A2. So last option is correct. Yeah, a simple question. Work done by the gravitational force or work done by the electrostatic force, because the forces are conservative. They are independent of the path followed. So gravitational field, let me read the question, question number 16. Gravitational field present in a region of and a mass m is shifted from A to B to different paths as shown. So this is a diagram. So W1, W2, W3 represent the work done by the gravitational force along the respective paths. Then this is given NEET 22 re-exam. Remember, independent of the path followed. So therefore, work done by the conservative force. So gravitational force is one of the conservative force. So how will we distinguish the conservative force? The equation or the law follows inverse square. This is similar to electrostatics, Coulomb's law. 1 by 4 by epsilon naught when two charges are in the vacuum. Q1, Q2 by R square. So therefore, electrostatic force is conservative, gravitational force is also conservative. Not only this, whichever the law which follows square of the distance. So therefore, they are conservative. So now first option is correct. In all the paths, final point and initial point same to reach. So therefore, independent of the path followed. Moving to the last question. So this is based on integration. So get back the relation in field line charges or potential capacitance. Potential difference between any 2 points is in a uniform electric field, E dot dx. Just you similarize the same formula here in gravitation. Gravitational potential difference is equal to intensity of gravitation, gravitational field intensity, Eg dot dx. So we need to follow integration type here to get the answer. So question is gravitational field intensity. So even we can also write gravitational field intensity is the potential gradient minus dVg by dx. So therefore, minus d by dx. So the quantity which is given is minus k by x is equal to gravitational field intensity. Therefore, minus minus become plus. A let us write outside d by dx x to the power of minus 1 is equal to gravitational field intensity. Now, so this is going to be minus 1. This is going to be minus 1 with k and x to the power of minus 1 is equal to Eg. This can also be written as minus 1 k by x square. So we need to substitute x value as 2 because you don't have any other this one variable. If x is equal to x square become 4. So k by 4 is the answer. Third option is correct. Thank you very much, students. In the next video, I'll continue explanation for previous NEET questions which are given in the chapters, units and measurements. But don't forget to share and subscribe with your friends and relatives.